The first property is that we have already seen this. What is xt convolution delta t? If we convolve any signal with delta function, what is this integral? Integral minus infinity to infinity x tau. Is it this? This is the convolution integral. Now tell me, what is this integral? Can we simplify this? Can we simplify this? When will this be non-zero? This is a function of tau. T is a constant. When will it be non-zero? When
At
tau is
equal to t.
Tau is equal to t. So can we write it as xt into minus infinity to delta t minus tau d tau? Because when tau is equal to t, this is xt. It is a constant with respect to that integration. You can take it outside the integral. What is this? What is this?
1.
What is this integral? It is area under impulse, shifted impulse. It is 1. So this is xt. Is it? In fact, this was the starting point in finding that impulse response of a system, how to express output related to impulse response, isn't it? We started from this point. Okay, so this is the first property of convolution. We can say that delta t is the identity operator for convolution. Okay, if you convolve any signal with a delta function, you will get the same signal. Now, what about this? If you are convolving any signal with delta t minus t naught, a delayed version of impulse, convolving any signal with a delayed version of impulse, delayed delta function.
Sir, x of t naught.
So we will get the delayed version.
We'll get the delayed version. Let us prove that. It is integral minus infinity to infinity x tau. What about this? Delta. But is it t minus tau minus t naught?
T minus t naught.
Sorry? It is t minus tau minus t naught because it is a delayed delta function. Is it? Are you confused with this? If you are confused, then take x1t as delta t minus tau. Now, what is the convolution of xt and x1t? It is integral minus infinity to infinity x tau x1t minus tau d tau. Okay. Now you replace, substitute this. What will you get? Is it minus infinity to infinity x tau delta t minus tau minus t naught? Is it that?
Yes, sir.
Now what is this integral? When will this be non-zero? Tau, it is integration with respect to tau. It is non-zero only when? When is that? When tau is equal to?
T minus t naught.
T minus t naught. So this is integral minus infinity to infinity xt minus t naught delta t minus tau minus t naught d tau. Okay. Now what is that integral? Integration with respect to tau. This is a constant. We can take it outside. Xt naught, xt minus t naught. What is this? This integral? Area under an impulse. Shift, even if you shift that, that will remain 1. Because you are integrating from minus to infinity to infinity. This is an impulse. And if you shift that impulse by t naught, this is a delayed impulse. Okay. Now, if you find the area, that is also 1. So is it xt minus t naught?
Yes, sir.
So what is that property? If you convolve a signal, any signal with a delayed delta function, then what will be the output? What is xt minus t naught? The signal will be delayed by t naught. Is it that? You take any signal, convolve with a delayed delta function, you will get a delayed version of that signal, delayed by the same amount. Is it?
Yes, sir.
So that is the property of convolution. Okay, we'll discuss the remaining property. That is x1t if we convolve three signals x1t, x2t, and x3t, then we can write it as okay, that is the associative property. And next property is the distributive property of convolution, that is x1t convolution x3t plus x4t. Sorry, x2t plus x3t, that is x1t convolution x2t plus x1t convolution x3t. Okay, that is the distributive property of convolution. Then the next property is if x1t convolution x2t is, let's say, yt. Now, can you tell me what is this convolution? x2t minus t naught? Yt is the convolution of x1t and x2t. Now we are delaying one of those signals, x2 t minus t naught. What will be that convolution? I think we have seen some examples of this. If we delay one of the signals, what happens?
Y of t minus t naught.
It is y of t also delayed by the same amount. It is very easy to prove. Can we write this as x1t convolution x2t? What is x2t minus t naught? Can we write it as x2t convolution delta t minus t naught? Is it this? That is the property
Yes,
of delta function. If we convolve with a delayed delta function, the signal will be delayed by that amount. Okay. Now we can use which property? We can use the associative property. This is same as what? x1t convolution x2t. Isn't it? What is this? It is given yt. So this is equal to yt convolution delta t minus t naught. What is that? Is it yt minus t naught? Convolving yt with delta t minus t naught. So we'll get a delayed version of yt, isn't it? So that is the time delay property of convolution. And we can generalize this if x1t convolution x2t is yt. Then what about this x1, let's say t1 t minus t1. The first signal is delayed by t1 and the second signal is delayed by t2. What is that convolution in terms of yt? First signal delayed by t1, second delayed by t2. What is that convolution?
Y of p minus t1 minus t2.
It is y of t minus t1. Okay, this one, isn't it? So we can say that if the first signal is delayed by t1, second signal delayed by t2, then yt is delayed by how much? t1 plus t2. That sum of these two delays. Okay. It is also very easy to prove. This is x1t convolution delta t minus t1. This is x2 t convolution delta t minus t2. Then you rearrange those terms, use the associative property, you will get this result. Okay. So these are the properties, and another property is if x1t convolution x2t is yt, then what about a constant times x1t convolution x2t? What is this? Multiplying with a constant. What will happen?
A by t.
It is a by t. It is straightforward. This if you put this is integral minus infinity to infinity x1 tau x2 t minus tau d tau. So you put x1t, replace x1t with a x1t, you will get that result. Okay, this is a times yt. So these are the properties of main properties of convolution. There is one more property, duration. Suppose if we have a signal, let's say x1t, this is from 0 to t1, x2t, let's say this is from 0 to t2. That means these two are finite duration signal. Finite duration means it is non-zero only in a finite interval. Those signals are called finite duration signals. Suppose x1t is a finite duration signal with duration t1, x2t, t2. Now, can you tell me what is the what about this x1t convolution x2t? Will it be a finite duration signal? The convolution of these two?
Yes, sir.
What will be the duration? If it is finite duration, what will be the duration?
0 to minimum of T1 or
No, I
T2.
am asking about T1 and T2. In terms of T1 duration. Okay, let us see what is that convolution. What is the convolution operation? This is x1 tau, and you have to flip the second signal. Where is this point? If you flip the, you have to find x2 t minus tau, isn't it? x1 tau, multiply these two, find the area. That is the convolution operation. Now, if you flip the signal and delay by t, where is this point? What is convolution operation?
T.
This is t and this point is where? T minus t2, isn't it? Flip this signal, delay by t, then this is x2 t minus tau. Now you have to move this point from minus infinity to infinity, find the, multiply these two signals, find the area. That is the convolution operation. Now can you tell me what is the duration of that? Duration means duration in which it is non-zero.
T1 plus T2.
It is T1 plus T2, isn't it? Because if we start this from minus infinity, until this point reaches here, there will not be any overlap. It will be 0. The overlap starts from 0. So T, and where will that end? The overlap. If we keep on moving this towards right, until this point reaches here. Where is that point? Is it T1 plus T2? Until T minus T2 reaches T1, that is T is equal to T1 plus T2. So the duration of this convolution, duration of the convolution of these two signals is what? T1 plus T2. So can we say that the convolution of two finite duration signals is always a finite duration signal? Is it true? Convolution of two finite duration signals is always a finite duration signal. If T1 and T2 are finite, T1 plus T2 is also finite, isn't it? Is it? If one of these signals is infinite duration, then what will happen? One of these signals is having infinite duration, then convolution is also what? Finite or infinite duration. It is also an infinite duration signal. Okay, now there is a slight difference here between the continuous time convolution, duration of the continuous time convolution and discrete time convolution. If we consider discrete time convolution, x1n, consider two discrete sequences, x1n and x2n. Okay. Now let us assume that x1n is duration n1. This is duration n2. Let me draw it here. So n1 duration means it is having some, okay, it is from 0 to n minus 1, isn't it? Is it 0 to n minus 1 or n? What is the length of this? This is n1, isn't it? Sorry, it is n1 minus 1. So we can say that, let's say this is signal x1n. This is a signal of duration having duration n1 because it is non-zero from 0 to n1 minus 1. Now if you consider the second signal, let's say it is non-zero from 0 to n2 minus 1. Okay, so this is a signal of having duration n2. Now can you tell me what is the duration of this resulting signal, let's say yn? Is it n1 plus n2? What is this summation? This is summation over k, x1 k, x2 n minus k. That is the discrete time convolution summation. That means you have to flip this signal, delay by n, multiply these two signals, and then find the sum. Is it?
Yes, sir.
So if we flip it, let's say I'm flipping this signal. Where is this point? Flipping and delay by n. Is this point at n? Because 0 will move, delay by n means this 0 will move to n. And what about this point?
N minus N2 minus 1.
It is n minus n2 minus 1 or plus 1?
The brackets 2 minus
Okay,
1.
bracket minus. Okay, I'm writing it like this. So it is non-zero in this interval. Now tell me in which interval the convolution of these two will be non-zero?
Sir, n is equals to 0 to n1 plus n2 minus 2.
And what is the duration of that?
So n1 plus n2 minus 1.
It is n1 plus n2 minus 1. Okay. You can easily verify that. So that is the duration of discrete time convolution. So here also, if one of the signals is of finite duration, then the resulting signal, the convolution of those two signals will also be infinite duration signal. Okay. Now let us consider an example that uses these properties of convolution. Let us find the convolution of these two signals.
So could you explain the discrete time interval again?
So is this the convolution operation? The first signal 0 to n minus 1, second 0 to n2 minus 1, isn't it? That's what this
Yes,
is
sir.
having duration n1 and this is having duration n2. Now the convolution operation means you have to flip this signal, delay by n, multiply those two, find the sum. Is it the convolution operation? Convolution summation? Now if
Yes,
you
sir.
flip this signal, this point is at 0. When you delay it by n, this is at n. This point, this sample. And this sample, this will move to n minus n2 plus 1. Isn't it?
Yes, sir.
Now if you then what is the convolution operation? You have to move this point from minus infinity to infinity and multiply these two signals, find the sum. Now when we move this from minus infinity, when will that overlap starts? When this point reaches 0, isn't it? So when n is 0, the overlap starts and it lasts up to which point? Which value of n? When this point reaches here, this point, if you keep on moving this towards right, when this point reaches here, the overlap stops, isn't it? Is it? After that,
Yes, sir.
there will not be any overlap. And which is that point? It is n is equal to n1 plus n2 minus 2. Is it that? Now
Yes, sir.
a signal is from duration non-zero in this interval 0 to n1 plus n2 minus 2. That is having a length. Duration is n1 plus n2 minus 1. Okay?
Understood, sir.
Okay. Okay, so now let us consider an example using the properties, how these properties of convolution can simplify convolution operation. Let's consider the convolution of these two signals. Let's say this is x1t, 1, 0, 1, 1. This is minus 1. Convolution of this with the same signal. Okay, sorry, this is 2. Okay. So can you find the convolution of these two? Is it difficult to visualize? You have to flip this, move it from, if you flip this, you will get something like this. Okay. Then this point is at t because this is 0 to t. Then this is at t minus 2. Then move this t from minus infinity to infinity. Multiply these two signals, find the area. Can you tell me what is the convolution? Is it, it is slightly difficult, isn't it? Because you have to see many overlapping areas. Now, can we simplify this convolution using properties of convolution? Can I write this signal as okay, this is 0, 1, 1 plus 1 minus 1. Is this signal sum of these two? Let's say this
Yes,
is
sir.
x2t and this is x3t. So can we, which property we can use? Can we use the distributive property of convolution? That is x1t, this is x1t convolution x2t plus x3t, isn't it? Is it? That is, if you use the distributive property, that is x1t convolution x2t plus x1t convolution x3t. Is it that? Now tell me what is this convolution? x1t convolution x2t. This is the signal x1t and you have to convolve with this one. Okay, 0, 1. Tell me the convolution. You have to flip this signal. This is 0, minus 1, 1, 1, 2. You have to flip the second signal. Okay, where is this point? Flip it and delay by t. Where is this point?
T.
This is a t and this is t minus 1. Move this t from minus infinity to infinity. Multiply these two signals. Find the area. Is it? So tell me what is that convolution? When this reaches, until this point reaches 0, there is no overlap, isn't it? If you move it from minus infinity towards right, until this point reaches 0, there is no overlap. So the convolution of these two is 0 till 0. Then what happens?
Linear increase.
It increases linearly till where?
1.
Till 1. Then
Linearly decreasing.
then what happens? It linearly decreases till
2.
Till 2. Till this point reaches 2. What is the value when this reaches? Okay, here if it is everything is linear, if you want to find the convolution in an interval, you start from the first you find at the beginning and the end point. Everything in between will be linear. So here it is when this t is 1, this rectangle is entirely completely overlapping with this part. So when you multiply these two, it is 1. So this one area is 1. Now what happens if we keep on moving this towards right of this one? What will happen? Area will increase or decrease. For example, if you consider t at some point here, is it something like this? So some part is negative and some part is positive. If we multiply these two and find the area, isn't it? So will it decrease the area, or is the area decreasing or increasing?
Decrease.
Decreasing till
So decreasing with higher slope.
decreasing. Anyway, that is a linear decrease, isn't it? It decreases linearly. Okay. And if we keep on moving towards right, where will it have its minimum value?
0.
Is it 0? Or if when this point reaches 2, what is that? Is it this? Something like
1.
this? This is 1 and this
Yes,
is
sir.
-1. Multiply these two, -1. So can we say that at 2, this is -1? Is it that?
Yes, sir.
It is linear. Okay, even though my drawing is not linear, this is linear. Then what happens?
Increases with the linear slope up to 3. T
Yeah,
equals to 3 and then becomes 0.
Sorry? Increases?
Up to 3 and then becomes 0. The signal will become.
Okay, is this the signal?
Yes, sir.
Okay, that is the convolution of these two. Now tell me, what is the convolution? Okay. Our objective is to find the convolution of these two signals. What we are doing is we are using the distributive property of convolution to simplify that. So first we found this. Now what about this? Can we use the property? What is this? What is the relation between these two signals?
Time shifting by 1.
It is delayed by 1. Not only delay, there is what? This is 1 and
Minus
this
sign.
is
Multiplied by
-1.
-1.
So can we say that x2t is minus x1t minus 1? Is it? Now tell me, what is the convolution of these two? We know the convolution of this. What about the convolution of these two? But
So inverted
So
and shifted
same
by
signal
1.
shifted by 1 and
same
magnitude
signal
multiplied.
shifted by 1 and inverted means delayed by multiplied by 1. So is it something
One.
like this? This is, let me draw it. This point is 1, 2, 3. So here, shift it right by 1 means, and then you have to multiply by -1, isn't it? So is it like this? Till -2? Sorry, till 2. Shift it right, multiply by -1 with -1. So this is this the signal in this interval 1 to 2?
Yes, sir.
Then 2 to 3. Is it this?
Will go. Yes.
And where is this? This point is, this is -1. So it is shifted right, multiply with 1. Is it this? 1. Then is it this?
Yes.
That is the shifted. We shift this by 1 and multiply with -1. Now what is the sum of these two? The convolution is then sum of these two, isn't it? Because we are using the distributive property of convolution. Can you tell me what is the shape of that signal, sum of these two? Start with 0, till 0, it is 0. Then what happens? Increases linearly because this part is 0. So this is 1, 1. Then what happens? In this interval between 1 and 2, it is sum of these two signals, isn't it? Both are linear.
So it will go up to -3 when t equals to 2. Sorry,
Yeah,
-2 when t equals
because
to
both
2.
are linear, you have to start. You have to find the values only at the end points of that interval, and everything in between is linear. So at 1, this is 0, 0 plus 1, 1, and at 2, this is -1, and this is what? This is also -1. So is it -2? Is it like this? Find
Yes,
the
sir.
value of the endpoints. Everything is linear in between. Now what happens at 3? So this is the value. What is the value at sum of these two at 3? Is it 1?
1.
1. So again linear. Then 4. Is it that? Is it the convolution? Is it? Is this the sum of
Yes,
these
sir.
two signals? This is the sum of these two signals. And what
Yes.
we
Yes,
have
sir.
done here is using the properties of convolution, we have simplified that convolution, isn't it? Otherwise, if you directly use this convolution, it will be slightly difficult. You can find it, but it is slightly difficult. But if you use this property, you can simplify it. Okay. And when in the exams and tutorials, you can expect many problems like this using the property of convolution. Properties of convolution, you have to simplify this convolution. And I will not mention that you using this property, distributive property, simplify this. Okay. So your main thing is that you have to identify which property will simplify that convolution. Okay. So once you identify that property, then everything is simple. Okay, any question regarding this? Properties of convolution? Okay, if you don't have any question, then let us discuss some applications of these properties in analysis of LTI systems. Okay. So let us consider two LTI systems. And first one is having an impulse response H1t, and second one is having impulse response H2t. What connection is this? What is this connection called? This is the input to the first system, let's say xt, and we are giving the output of the first system as the input to this input of the second system. Is it that? What connection is this? What is it called?
Series connection?
Series connection, or is it cascade connection? It is also called the cascade connection, isn't it? Cascade. Output of one system is given as the input of the second system. Now, what is the output here? Output at this point, let me denote it by y1t. What is output? What is y1t? The impulse response of the first system is h1t and input is xt. Then what is y1t?
X, not convolution H1.
No, sorry, it is not x naught, it is xt only. Xt convolution h1t. Now tell me what is the output of the second system, yt?
X convolution H1
The
convolution
input to that system is xt convolution h1t. That convolution that is the input to the second system, and then convolve with H2T. Can we write it as XT convolution H1T convolution H2T using the associative property of convolution? Is it that? I'm using the associative property of convolution. What does it mean? What does it mean? Can we say that I have a system? Here using the associative property of convolution, we can write like this. Can we say that where is this true? Is this correct?
Yes, sir.
Yes, sir.
So what does it mean? If we have a cascade of two systems H1T and H2T, we can replace it with an equivalent system. And let's say HT is the equivalent, the impulse response of that equivalent system. What is the impulse response of HT? It is the convolution of H1T and H2T, isn't it? Is it that?
Yes.
Okay, so that is the cascade connection of two systems, and we can generalize it if you have cascade of n systems like H1T, H2T. Then the impulse response of the equivalent system is H1T convolution H2T. We can apply this for any number of systems if they are connected in cascade. Okay. And you can easily verify this also, like what is the cascade impulse response of a system? You give delta t as the input. If you are giving delta t, what is the output here? The system is having impulse response h1t. What does it mean? If you are giving delta t as the input, here it is h1t. Now h1t is given as the input to the second system. So what will be the output?
H1 convolution H2.
It is h1 convolution h2. Isn't it? Okay, now next property is so what you have seen is h2t. This is equivalent to, we can say that this is equivalent to a system having impulse response h1t convolution h2t. When we say equivalent, the meaning is that if you give a signal xt and getting yt as the output, if we give the same signal here, you'll get the same output here. Equivalent in this sense means we are talking about the input-output relation. The intermediate signals, okay, here there is no intermediate signal. Now what about this? I am interchanging the order of convolution, the order of that system. Okay, first the signal is passed through h2t, then h1t. Then what about the equivalent system? What is the impulse response of the equivalent system? Is it h2t convolution?
H2T.
H1t?
Yes,
Are
sir.
they same?
Yes, sir.
That is the commutative property of convolution, isn't it? So can we say that we can interchange the order of that cascade connection? Here I am changing the order. Here h1t, h2t. H2T, H1T. The output will be what? Will it be the same? Without changing the output, we can interchange the order of that cascade connection. Order means we can here first H1T and H2T, here H2T and H1T. Are they same? Will they give the same output? These two systems, cascade connections?
Yes, sir.
They will give the same result because the equivalent system is H1T convolution H2T and H2T convolution H1T. They are the same. So with respect to this input and output, they are the same. But remember, this intermediate signal is different in both the cases. Okay, here it is, these two are different, but the final output, that is the same. That are the same. Okay, is it clear, that property? So we can interchange the order of that system, cascade connection. Okay, using this we will prove an important property of linear time invariant system. If we have a system, is it a linear time invariant system? It is a differentiator. Is it a linear time invariant system? Differentiator is it an LTI system? Is it a linear time invariant system? This is remember, this is not the impulse response of this system. It is just I am denoting it. It is a differentiator. Input is xt, output is derivative of the input signal. Is it a linear time invariant system?
Yes, sir.
It is a linear time invariant system. I think there is a this was proved in this question was there in the first tutorial sheet. Prove that this is a linear time invariant system. Differentiator is a linear time invariant system. Now suppose we have a system, let's say LTI system having impulse response ht. Let's say the output corresponding to xt is yt. Okay. Now this is a linear time invariant system and I am passing it through a differentiator, and then is it that? I am considering this. Now can we interchange this order? This is equivalent to what? Is it equivalent to xt first, then ht? Because both are linear time invariant system, we can interchange the order. Is it that? Now tell me, what is this output? xt, if you are giving xt to that linear time invariant system, it is yt. Now tell me, what is this output? What is the output at this point?
YT.
It is yt. And what about this? Derivative of yt, because this is a differentiator, so it is the derivative of yt. Now what about this? What is the input to the system here? What is the input to the system, this linear time invariant system? What is the input at this point?
dx by dt.
It is the derivative of xt. So can we say that if we have a linear time invariant system and if the output corresponding to xt is yt, then what is the output corresponding to the derivative of that? We have a system, xt is the input, yt is the output. My question is, what is the output of that system if we are giving d by dt, the derivative of xt as the input?
Y dash t.
It is y dash t. That is what we have proved. So that is an important property of linear time invariant system. Take any signal. If you apply that signal to a linear time invariant system, any system, if you give xt as the input, if you get yt, now if you apply the derivative of this d by dt xt as the input to that system, what will be the output? What will be the output? It is the derivative of yt. If you take the derivative of this is also derivative of that. Okay, that is what we have proved here. Is it clear? Any question? Any question regarding this? And similarly, you can prove this if xt we have a system, if we are passing it through an integrator. Okay, integrator, I am writing it as minus infinity to t. That means the output is integral minus infinity to t x tau d tau. I am leaving this as an exercise. You can, this is a linear time invariant system. You can easily verify that. I think we have proved it in the tutorial class. This is an integrator. Integrator is a linear time invariant system. So the property is that if you have a linear time invariant system and if the output is yt, if you have a, okay, let me draw it like this. If we have a linear time invariant system having impulse response ht, if xt we are giving xt as the input and the output is yt, then to the same system, if we are giving the integral of xt as the input, what will be the output? This is a linear time invariant system. You can easily prove this. Same as that of differentiator. If you give xt as the input and getting yt, then to if you give integral of xt as the input to that the same system, then the output is this yt, integral of yt. Okay, this you can easily prove. Okay, now let us discuss parallel connection. We have seen cascade connection. What is parallel connection of two systems H1 and H2? H1T, H2T. Parallel means what? We are giving the same input to both the systems and then we are summing the output. Okay. Now, can you tell me whether we can replace this with a system, linear time invariant system having impulse response ht? These two are equivalent. What is impulse response of ht? What is the output here? Input, same input, we are applying same input to both the systems. This is having impulse response h1t and this is having our input h2t, impulse response h2t. What is the output of the first system?
X convolution H1.
It is xt convolution h1t. And what about this? xt convolution
X convolution H2.
h2t.
H2T.
And then what about this?
XT convolution H1T plus X2.
H1T plus H2.
Plus xt convolution h2t, is it? Now we can use the distributive property to simplify this. This is same as what? xt convolution what? h1t plus h2t. Is it that? Now tell me what is what is the impulse response of the equivalent system if the two systems
H1T plus H2T.
if two systems are connected in parallel, then the impulse response of the equivalent system is ht is h1t plus h2t. Okay. This is for parallel connection, and for cascade connection, H1T convolution, H2T, if they are connected in cascade. That is the difference. And same thing, these are all these properties are applicable to discrete time systems also. I'm taking examples of continuous time systems only. Okay. Okay, now let us consider a complex system. Let's say this is having impulse response H1, H2, what is the impulse response of this?
H1 plus H2 convolution
This is
H3
xt
whole
and
plus
yt. We can replace it with an equivalent system having impulse response ht, xt, yt. Okay. Now, what is this ht? These two are in parallel. Is it?
Yes,
H1
sir.
and H2 are in parallel. That parallel combination is in series with H3 because the sum of these two, the output is given as the input to H3. So what is this one? What is the impulse response? H1, H2 parallel means it is H1T plus H2T, that is impulse response of equivalent system. Then convolution H3T. Is it? That is the equivalent of this. Then finally, what?
Whole
This
plus H4T.
this whole plus, wait, that is the impulse response.